This short demonstration shows how Solid Edge Insight takes advantage of the latest Microsoft SharePoint platforms to deliver improved security and collaboration for design data management. We start by using the web portal. We'll see how users can get fast access to design data and how managers can track the progress of multiple design projects. Here, we're reviewing some company-specific best practices for designing with Solid Edge that are shared in a discussion area. And now we review our calendar. We select this design review meeting to review the details of an engineering change that has been proposed for one of our welding fixtures. We now run a search on the database. In this example, we search for Solid Edge files whose file names start with W10. This is our part number series for end plates. The underlying database is maintained using Microsoft SQL Server, and you can see how this results in fast searches. As we select the different parts retrieved by the search, a thumbnail preview is displayed, enabling fast graphical review of the different parts. We now search for the assembly that is the subject of the proposed design modification. Note that the interface contains tips on how to search on character strings. One assembly is returned by the search, and again we get a thumbnail preview that confirms that this is the correct assembly. Note also the menu of operations we can perform on this assembly from the web portal. We open this assembly in the dashboard. This enables us to do further visualization and analysis on the assembly without the need to run Solid Edge. For example, we can rotate the 3D assembly model and select individual parts from the bill of material for closer inspection. Note that the bill of material also shows us which parts are currently checked out by other users. We now select one of the tasks assigned to us. We change the status of this task to say we have started work and click on a link to a package collaboration file that details the proposed change. This opens the PCF file in the View and Markup tool. We can use this tool to analyze the assembly and display any markup information that has been added. We select the command to open the data for editing. In this case, this is a Solid Edge assembly, so the top-level assembly is transparently checked out of the Insight database and opened in Solid Edge. We know we want to modify the end block assembly, so we request that this be opened. The checkout operation happens transparently. Note that data management information, such as who has checked out any parts, is displayed in the assembly pathfinder. We need to modify the holes in this end block so we can recess the green bushings. So we select the hole feature and change the parameters that control the hole size. Since the bushings were aligned to the holes, you can see that they are automatically repositioned when the hole geometry is edited. We also need to replace the bolt. We select the existing bolt and click the Replace command. This automatically launches a search window so we can find the correct replacement part. We specify the type of bolt that we want and select the new bolt from those returned by the search. Solid Edge tells us that the bolt is used in 6 places and gives us the option to replace all occurrences, which we accept. We close the subassembly and return to the top-level assembly. When we close Solid Edge, the system detects which parts and assemblies have changed and presents a dialog that confirms that these parts will be checked back into the database automatically. Back in the web portal, we change the status of our task to completed. We browse the pre-released folder and note that with the new document level security and insight, only documents accessible to the user are displayed. We send the end plate subassembly to the dashboard and review the changes that have been made using the 3D viewer. We return to our home area to conclude this demonstration.